In addition to all the things you have learned so far from our platform, today we want to look at temperature and heat. Now, temperature is fundamental quantities, alright? So the fundamental quantities we have like mass, we have time, and we have length. So temperature is one of them. What does that mean? Fundamental quantities are those quantities that are independent of other quantities. Alright? So temperature, as many of you know, is the hotness and coldness of the body. But apart from that, something is resulting in the hotness and coldness of the body. So in most textbooks, they say temperature is the measure of the average kinetic energy of the particles in a substance. I don't know if you get that, right? Heat is a resultant effect of change in temperature. Once there is a temperature gradient, heat will flow. So heat is the measure of the total internal energy of a body. Alright? To further differentiate the difference between temperature and heat, temperature is measured in Kelvin, in Celsius and Fahrenheit, while heat is measured in joules. Alright? Other smaller quantity of or amount of heat are measured in calories. You understand what I'm saying? So now, also temperature is determined or measured with the instrument of thermometer or with the aid of thermometer. Alright? Heat is calculated using a calorimeter. Temperature is a fundamental quantity like we said, and heat is what? Derived quantity. Now, let's look at thermometer. We said temperature is measured by thermometer. Alright? So what are the things that we need to know about thermometer? First of all, thermometer must mean something that will respond to change in temperature. Alright? So and there are many things that respond to change in temperature. That is what helps us, to now have different thermometers with different substances. Okay? So those substances or those factors are called thermometric substance. The first one is our liquid in glass thermometer. This is a thermometer that responds to change in temperature, alright, as the volume of the liquid increases. Are you getting me now? So the liquid in glass thermometers are those thermometers that have liquid as their thermometric substance. The liquid include the mercury, the alcohol, and other substance, sometimes water, but most times water is not really used. Are you getting me now? So what is the thermometric property there? The property is that once there is change in temperature, their volume rises or expands. You understand what I'm saying? So let's list out all those thermometers and their thermometric substance. So we said thermometer, thermometric substance, so alright, it's very very important that we show you, the different thermometers and the thermometric substance that they work with. So the first one we said is thermometer, or liquid in glass thermometer, liquid in glass thermometer. Now, liquid in glass thermometer, we say those liquids, you have mercury, you have alcohol. Alright? So, what is the thermometric substance? Mercury, alcohol. Mercury or alcohol. Alcohol. What is the property? Change in volume with what? With change in temperature. So, as the temperature changes, the volume also responds. Are you with me? The volume responds as the temperature changes. So we have another one. So I look at constant volume thermometer. Constant volume thermometer. Okay, let me say constant volume gas thermometer. Constant volume gas thermometer. Now this one we have gas, alright? So gas is what? The thermometric substance, and the property is pressure. Alright? Change in the pressure of gas with change in temperature. Are you getting it now? So change in pressure. Change in pressure. Pressure of what? Gas with what? Change in what? In temperature. Are you getting it now? So this one is a response to pressure and temperature. That's law, alright? So now we have another one. That one is called electric thermometer. So thermoelectric thermometer, what is in this thermoelectric thermometer? You have two different wire or metals. Let me use metal, okay? So once they exchange different, maybe you have an ice and a hot water, I use two different wires to create a junction. It will set up what? A potential difference. So what we say? We say two different what? Two different metal. Example, copper and what? Copper and zinc. You can say copper and zinc. Alright, copper and zinc. So let's let it nicely down. So the property is what? Change in potential difference with change in temperature. Please, I hope you are taking note of this. So change in PV with what? With change in temperature. Are we together now? So the next one, resistance thermometer. So the thermometric substance is resistant wire, like your constantan wire, your mica wire, and all that. So resistance wire. So the property or the factor is that resistance changes with what? Change in temperature. So we say resistance, change in resistance, with what? With change in temperature. Are you with me? So now, the last but not the least is what? Bimetallic split. Bimetallic split. Now, what is the thermometric substance? The thermometric substance is iron and brass. I get it. Then the property is what? Expansion. Alright? The different expansion of the metal with what? Change in temperature. We have successfully looked at different thermometers and the substance that they work with. I get it. And the property that makes it a thermometric substance. I get it now. So for now, we want to look at the thermometers themselves. All right. So let's start with mercury in glass thermometer. In glass thermometer. So mercury in glass thermometer make use of mercury. And mercury is a very good material for the construction of thermometer. I get it is kind of silver colored. I get it. So once mercury rises on a narrow bore, you see the color going upward because it's silver white. I get it now. So that's number one. Then number two, mercury has a very high boiling point. I get it. So it gives us a very wide range of measuring temperature. So the boiling point of mercury is 360 degrees Celsius. So that means we can measure a range starting from minus 39 because the melting point of mercury is minus 39. So minus 39 to 360, that is a very wide range of temperature measurement. I get it. Then another thing is that mercury do not vaporize easily. Mercury, like I said, the boiling point is 360 degrees Celsius. So it doesn't vaporize as easy. Vaporization is just like, boiling up and turning to gas and escaping, you understand? So it doesn't vaporize easily. Now, the fourth one is that mercury has a very sharp response. It has a very sharp response to what? Temperature change. Are you getting me now? Now, also, mercury expands uniformly. Are you getting me now? Uniformly. All through the body, it responds to temperature change uniformly. So now, want to look at the next one, which is alcohol. Alcohol in glass. Alcohol in glass thermometer. So alcohol in glass thermometer is very useful, especially in the all this polar region. These places where they are very extremely low temperature. You can't really use mercury there. Alright, or you can't use mercury in glass thermometer as efficient as alcohol will be. Because alcohol has a very low melting point. The melting point of alcohol is minus 112 degrees Celsius. Can you see that? Minus 112 degrees Celsius. That's the melting point. Meaning alcohol cannot freeze at all. Alcohol cannot freeze in this part of the world. You understand? It takes a very extremely low temperature to freeze alcohol. Alright? So now alcohol is very important in the sense that it has what? Very low freezing point, very low freezing point. So it can be used to measure extremely low temperature. Then number two, alcohol expand, quicker than mercury. Alcohol expands 6 times the volume of what? Mercury in the same increase in what? Temperature. So those are the two important factors that alcohol has. You understand? So, but alcohol has disadvantage. Mercury also has disadvantage. Let's start with mercury. What's the disadvantage of mercury in glass thermometer? Number one, mercury is very expensive. So to have a thermometer constructed with mercury is going to cost much more than alcohol. You understand? Alcohol is cheap. You understand? Then number two, mercury freezing point is minus 39. And that means it cannot measure lower temperature than 39. And it can be used, like I said, in all those ice regions. You can see that's the advantage, disadvantage of mercury. I get me now. So now, let's look at alcohol. Number one, alcohol is not really a good substance for, determining, constructing a thermometer. I know it is used in the polar region, but before it is used, it has to be colored because alcohol is colorless. So that's the disadvantage. Alcohol is colorless. Number two, alcohol has a boiling point of 78 degrees. Can you see? So 78 degrees Celsius, alcohol is already boiled and vaporized. So it can vaporize very easily. Number three, alcohol does not expand uniformly like mercury. Then alcohol wet glass like water. It's almost like water. It's wet glass. And that's the disadvantage. I get it now. So apart from that, alcohol makes us really low temperature. I get it. So that's just it. Alright. So now we want to look at okay, let's look at constant volume thermometer. Let's look at constant gas volume thermometer. Now the gas constant uh, volume gas thermometer. Constant volume gas thermometer is really the best thermometer that can be used. The best thermometer that can be used because it has the widest range of measurement in terms of all, the thermometer or something. Let me just use that one. It has a very wide range of measurement. I get it. Number two, gas, the property is gas. So gas response, the response will be very, very accurate and intentional. You understand what I mean? So constant volume thermometer is the most accurate thermometer. Alright, the most accurate thermometer. Alright, so it responds very quickly and very efficient. So the disadvantage is that the thermometer is really cumbersome. It's not just there are two. We have our YouTube and our this thing. What do you call it? The gas, yeah. I get it. So these two things are made just to get one thermometer. So it's very cumbersome. You understand? It's very, very cumbersome. You understand? So that's the disadvantage for constant volume thermometer, and it's very, very expensive. That's also a disadvantage for mercury. I said it before. So this one is very expensive to construct. So apart from that, it's the most accurate thermometer. I hope you get that. So now, want to look at constructing our thermometer. So when we want to construct our thermometer, we need to take our upper fixed point, and our lower fixed point. I get it now. The upper fixed point and the lower fixed point. Alright, for our thermometer. So the upper fixed point, alright, is defined as the temperature at which pure water will boil. You understand me? So the lower fixed point is the temperature at which ice melt, pure ice, at a particular at a standard pressure, standard atmospheric pressure. Please take note of that. When you talk of boiling point, the pressure affects boiling point. You understand me? For instance, if you go, the higher you go, the lower the boiling point of water. You can see pressure affects. So we're talking of standard atmospheric pressure. I hope you understand that. Alright, so since we are considering our upper fixed point and our lower fixed point, I think it's very important we look at a very important thermometer called a clinical thermometer. So clinical thermometer. So the clinical thermometer, I will draw a diagram, an outline to show our clinical thermometer. So let's assume that this is our clinical thermometer. Alright. So let's just set this one like this. So this is our bulb. Alright. Our bulb. You can see that out is clear. Alright. So now this is constriction. Alright, you can see the graduation. The graduation starts from 35. Hmm? So 35 to 43. Take notes. So our clinical thermometer starts from 35 degrees to 43 degrees. Very, very important for those of you, taking exam under this. So now, the human body of a healthy person has a temperature of 37 degrees. Healthy people have 37 degrees as their Healthy people have 37 degrees as their temperature. So that's the normal temperature of the human body. So now look at this constitution. Very, very important. This constitution is used or constructed in order to prevent the mercury from overflowing, and it holds it, the kind of hold it and prevent it from overflowing. So when you take a measurement, let's say you take a measurement and it comes to this point. Are you getting it now? It will remain there. It will remain there till you take after you have looked at, the temperature that was already measured, then you can now, shake to return the mercury that has poured out back to the bulb. You understand? So this constitution is very, very important, alright? Very, very, very. Now, temperature is measured in Kelvin, Celsius degree, and degree Fahrenheit. Are you getting it now? So if we want to use our scale, upper fish point and lower fish point, alright, so we know that the temperature of the boiling water is 100 degrees Celsius on the Celsius scale. So the temperature of ice, electric ice, is what? 0 degrees Celsius. So if we want to look at that at the other end, which is Fahrenheit scale, it will be 212 degrees Fahrenheit. Temperature of the boiling water is 212 degrees Fahrenheit. Then for a pure ice, it is what? 32 degrees Fahrenheit. Now, this scale or outline will help us to be able to convert from one side to the other. Are you getting me now? Now, I want to remind you, the difference between this and this is what we call fundamental interval. And the difference between this and this is called fundamental interval. Very, very important. So this minus this will give you 180. And this minus this will still give you 100 degrees Celsius. Alright? So if we have a temperature of, let's say, 32 degrees Celsius, what will it be in Fahrenheit scale? This is where this diagram is very important. That it helps us to create a very, very important formula. So this formula, what is this minus this, this minus this. So let's just call this place x. This minus this will give you s minus 0 over this upper fish point minus lower fish point, which is fundamental interval. So that's 100 degrees Celsius minus 0 degrees Celsius. Are you seeing that? So that is equal to the same thing here. This minus this, that's theta minus 32. Alright, theta minus 32 all over what? 212 degrees Fahrenheit minus what? 32 degrees Fahrenheit. Are you seeing that? I hope it's clear. I hope it's clear now. You can see that, right? So this is the formula which I use to move from different range. Mind you, some other things you can do in that your question is that they might not really give you a particular fixed point. They will give you interval. alright, intervals, like the idea in the fundamental interval, they will now say it in the scale. You understand? Different ways of answering the question. Now, also, okay, if you want to answer this question now, by the time you slot in 32 into this place, you're going to get your answer. And I will encourage you to do that. You can pause the video and do that so that you can see your own answer. Alright, now, we want to look at since we have different instruments for measuring temperature or different thermometers, now they have different properties. Alright, you have the resistance, you have the potential difference, and you have the length or the distance. They have different properties that they use to determine this temperature. So because of that, we can also use this our outline to determine the temperature for any of those thermometers. So let's assume that we have a thermometer, our mercury glass thermometer. It is still in volume, right? So when we're talking of volume, we might not really concern ourselves with the cross-sectional area. Let's look at the length. So let's see the upper fixed point of the mercury glass thermometer is let's say 20 centimeters, and the lower fixed point is at let's say okay, you can say let me just say 8 centimeters. Now, if the upper fixed point is 20 centimeters and the lower fixed point is at 80 centimeters, so if there is a rise in the mercury level to a level of let's say 18 centimeters, what will be the temperature on that mercury in glass thermometer? Can you see that? So you just use this whole value given to you and compare it to your upper fixed point, lower fixed point, and the temperature you are looking for. Okay, so like I said, you follow the formula. You say this minus this over this minus this. Alright? And equal to what? This minus this over this minus this. So let's look at the answer it gives us. So we have 18 degrees minus 18 centimeters, minus 8 centimeters over what? 20 centimeters minus 8 centimeters equal to theta minus 0 over what? 100 minus 0. So what you have? 10 over 12. 18 minus 8, 10. 20 minus 8, 12. Equal to what? Theta. Theta minus 0, theta over what? 100. So when you divide, this is 4, we have what? 25. 4 here, we have 3. Okay? You cross multiply, that means that theta is equal to 250 over 3. And that would be what? 6 point what? 6. 3 is 25, that's 6. 3 is 25. Okay, that is not 6, it's more than 6. 3 is 25, that is 8, 8. Now, 3 is 10, that's 3.333, you can see, degree Celsius. You understand what I'm saying now? It might not be centimeter, it could be millimeter or resistance. 3 ohms, 10 ohms, just understand which of them is corresponding to the upper fixed point and which of them is corresponding to the lower fixed point. We're going to look at effect of heat. So what are the resultant effects of heat? Number 1, expansion. Once there is addition of heat, the material will tend to expand. Number 2, you have change in temperature. Once there is addition of heat, temperature will increase, or when we extract heat, temperature will drop. Now also, we look at the change in the state of matter. Matter changes from liquid to gas or from solid to liquid because of temperature. There are many applications of temperature and effect of temperature, but I would like to stop here because the video is, so we're going to solve questions in relation to what we have just discussed. Please like and make comment and share the video to your friends so that they can also learn what you are learning now. Thank you.